Hi, good morning everyone. Today we will discuss some more questions of cube root of unity. So in this first question, we will discuss about that is not in your exercise but that are important question in the board point of view. So I will discuss it here. Like if I have a question, if omega is a complex cube root of unity and x is equal to omega square minus omega minus 2, find the value of x4 plus 5x cube plus 9x square minus x minus 11. So this is my polynomial equation. Okay, before finding the value of this polynomial equation, I will find the proper equation of this which is given to me, like x is equal to omega square minus omega minus 2. Okay, so first I will arrange this in the proper quadratic equation form. So then I will go further to find the value of this polynomial equation. So for this, first I will shift this constant term on the left side, like x plus 2 is equal to omega square minus omega. Now my next target is I have to remove omega on the right side, because in my quadratic equation there should not be any complex root is there, that only I am able to find the any polynomial equation value. So what I do in that case, so I will go with squaring both sides. When I go with squaring both sides here, so x plus 2 whole square give me x square plus 4x plus 4, and on the right side when I apply e minus b whole square formula, so that is omega 4 plus omega square minus 2 omega square into omega. So omega 4 value is omega 3 into omega plus omega square, and this is minus 2 omega cube. So when I solve that one, omega cube value is 1. So only omega plus omega square is left, and this is minus 2 is left. Now here I go with this value. So I have this condition 1 plus omega square is equal to 0. So if I extract omega plus omega square value from here, so that is equal to minus 1, minus 2. So that means this equation x square plus 4x plus 4 is equal to minus 3. So when I make it proper equation, then 4 plus 3 give me 7 is equal to 0. Okay, that means now I have to divide this equation with this, because this is the divisor and this is the dividend. So when I divide this, then I will check what will be my answer in that case. So next is I have to divide this by this, like this dividend by this divisor, like x4 plus 5x cube plus 9x square minus x minus 11. So I will check what answer I get after that. So now I divide this by this equation, x square plus 4x plus 7. First I want to remove this x4, so I multiply with x cube. So that give me x4 plus 4x cube, then plus 7x square, then minus, if you subtract this one, 5 minus 4 give me x cube, 9 minus 7 give me plus 2x square, then carry on minus x. Now next target is I have to remove x cube, so I multiply with x, like plus x. So that give me x cube plus 4x square, then plus 7x. So if I subtract this one, so 2 minus 4 give me minus 2x square, then minus 8x, then minus 11. Now my next target is I have to remove minus 2x square. So I multiply with negative of the 2 here. So minus 2x square and minus 2 into 4 minus 8x. Then it give me minus 14. Now if you subtract, sign will be changed. And here 14 minus 11 give me plus 3. So that is a remainder. So that means when you're going to write this dividend, our rule is that dividend is equal to divisor into quotient plus remainder. We apply the rule it here. Okay, when I apply the rule here, my dividend is x4 plus 5x cube plus 9x square minus x minus 11. So that is equal to my divisor x square plus 4x plus 7 multiply by quotient x square plus x minus 2 plus remainder according to my rule. So here if I look at this x square plus 4x plus 7, I already find that in my top of the equation that is equal to 0. If this is equal to 0, on this part all will be my 0. If this part will be 0, what is left? Only 3 is left. So that is my answer. So that is the required value of this polynomial equation. So this way you can find the equation, polynomial equation value. Next question is, if omega is a cube root of unity, you have to show that a plus b omega plus c omega square upon c plus a omega plus b omega square, a plus b omega plus c omega square upon b plus c omega plus a omega square must be equal to -1. That means you have to prove left side with the right side. First I will pick here left side. So if you just pick the left side, you will check which variable is without omega. In the upper part it is a and in the downward is c. Okay, so I need here, because in the upper part c company with the omega square, so that means I have to multiply the denominator whole value with the omega square to get this c omega square. In the second case, when I check here, so b is without any omega and upward is a. In this case you only check the downward term who is without omega, so you can check from the upward. So which term of omega is multiplied with this b? So that is only single omega. That means you have to multiply numerator and denominator with omega raised to power 1, and here c accompany with omega square, so you have to multiply this numerator and denominator with the omega square. So when you multiply with this omega square, a plus b omega plus c omega square, and denominator omega square c plus a omega plus b omega square. You only have to multiply denominator with this omega square, no need to multiply with upward. Okay, here is also same. When you multiply with this omega, numerator and denominator, only you have to multiply with the denominator, no need to multiply with the upper part, because I want to cancel the term upward to make it a same term. So when you multiply this only denominator, upper term will be right as it is, a plus b omega plus c omega square, and here c omega square plus a omega cube plus b omega 4, and here also upper term right as it is, a plus b omega plus c omega square, then in the denominator b omega plus c omega square plus a omega cube. Okay, wherever we get a omega cube, we get it 1, we convert into 1, and omega 4, because omega 4 means you have to multiply omega 3 with the omega, so omega 3 value is 1, and that means omega 4 is equal to omega. So instead of omega 4 you have to write only omega. So upper term write as it is, omega square a plus b omega plus c omega square, and denominator is c omega square plus a plus b omega. That is exactly upward the bracket term. Here also this is a plus b omega plus c omega square, and here b omega plus c omega square plus omega cube becomes 1, and it is a. So this bracket will be cancelled with each other, only omega square plus omega is left, and our sum of cube root of unity is always equal to 1, like this is equal to 0. So that is our formula. If we accept omega square plus omega value, that is equal to -1, that is exactly equal to the right hand side. So this type of question you have to prove like that. First you have to check only the constant term in the denominator and which omega is multiplied in the numerator, this same constant term in the numerator. So this way you can easily identify which omega or omega square you have to multiply. My third very important question is, if 1 omega square are the cube roots of unity, prove that. This is also our property, is that if 1 omega square are the cube root of unity, you have to prove that 1 omega square are the vertices of the equilateral triangle. So if these are the vertices of the equilateral triangle. So we consider as this as 1 omega square. So okay, if this is equilateral triangle, so that means distance between this will be same. Okay, so you have to go with that. So in this case, if I go with the distance formula, so that will be 1. If we go with AB, like this is my omega vertices, this is my omega square, because we consider that these three complex roots, these are three roots, are the vertices of the equilateral triangle. So that we have to prove by applying these vertices, maybe our triangle will be the equilateral triangle or not. So in that case, we take the omega value, that is my actual root value, that is -1 plus root 3i by 2 and omega square value will be -1 minus root 3i by 2. So now what I will do, first we try to find the distance. What is the distance between these all terms? So if you go with AB, distance of this, that is distance modulus of 1 minus omega. So I apply it here, omega value. So that is 1 minus -1 plus root 3i by 2 modulus. Okay, when you take the LCM of this one, so this will be, this is -1 it here and negative sign it outside. So when you take the LCM, 2 minus become +1, and here negative and positive become negative root 3i by 2. So that gives me 3 by 2 minus root 3 by 2i. After that, you have to find the modulus of the complex numbers. So that is square of the real part plus square of the imaginary part. So that is 3 by 4. I am directly write it here. So that is also 3 by 4. 3 by 4, sorry, this will become 9 by 4 because this was the root 3. So that is a square root. So when you solve that one, so that becomes 9 by 4 plus 3 by 4 square root. So this is 12 by 4. 12 by 4. So that gives me root 3. That means my AB value is root 3. Now I go with further. Similarly, if I go with the BC value here, the modulus of BC, so that is modulus of omega minus omega square. Now you have to go with the subtraction of this two. If you go with the subtraction of this two, like BC value, so I go with BC value here in the next page. So in the BC, that is omega minus omega square, I apply the exact complex value -1 plus root 3i by 2 minus -1 minus root 3i by 2 modulus. When you go with this, like here, so when you take the LCM, -1 plus root 3i plus 1 plus root 3i, then 1 will be cancelled, then 2 root 3i by 2 is left. So only here imaginary part is left, 0 plus root 3i under the modulus. So when you find the modulus of this complex number, like real part square plus imaginary part square, so this square root will be cancelled and root 3 will left. That means AB and BC are equal to each other. Only last is left, CA. Now I go with CA. So that is 1 minus omega square. So my omega square value is -1 minus root 3i by 2. So this is 1. I will take the LCM. 2 plus 1, then plus root 3i by 2. So that give me 3 by 2 plus root 3 by 2 I and modulus. After that you go with the modulus of this real part square plus imaginary part square and square root. So that is 9 by 4 plus 3 by 4 square root. Again it will be 12 by 4 and gives me root 3. So that means if my all distance is same, EB is equal to BC is equal to CA, we can say that these three roots of cube root of unity in the complex plane represent as a equilateral triangle.